So this is the third video to explain parts of this Newton's second law experiment. I'm going through part 2, understanding the equation F equals ma, or force equals mass times acceleration. Your final project for the forces unit will be to use the mathematics of Newton's second law to explain why two friends don't enjoy the same experience when they discover a fun toy. You'll see. That's a little teaser for tomorrow's assignment. If you want to know a little bit more about it, I did explain it in the first minute or 2 minutes of part 1 of 3. So if you want to go back and watch that, please go ahead. The following is practice to get you ready. For the following questions, switch to the acceleration tab and check all the boxes in the menu to the left. So I already clicked on this to go to the acceleration tab, and I actually like to have a split screen, so I have it open right over here. Question 9, research question. How does force affect acceleration? So over the questions 9 through 12 are all seeking to answer this research question. How does force affect acceleration? We're going to have controlled variables. So our mass is going to be 50 kilograms. We're going to be using this box. And friction is going to be 94 newtons. If I'm being totally honest, this is the hardest part of setting up this experiment, is getting the friction down to 94 newtons. I'll show you how to do that. Directions. Complete the data table to gather evidence in order to answer the research question above. So we're going to go to show your work. I did have to do a little bit of change here because since we have a friction force of 94 newtons and we apply a force of 100 to start us off, the net force should be 6. So if you did this earlier and you see that it said 0 there, please just, you'll notice that you should change it to 6 there. Okay, it'll make your data look a lot better too. You'll see. Okay, so first I will apply a force of 100 newtons. Now the way we have friction set up right now is that it's pushing back with a force of 100 newtons. So what I need to do is I need to decrease the friction a lot to get it started, and then I can kind of move it back over until I can get it to 94 newtons. Okay, so we can see that we have a sum of forces, or a net force of 6 newtons right here. That's where that 6 is coming from. All right, so we can see that applied force of 100 newtons and our net force of 6 newtons. Now I'm going to pause it because if the speed gets too high, this box gets away from this person. So I want to be able to use these settings for the rest of this. All right, so our acceleration is 0.12 meters per second. I'm going to go to the text box and click 0.12. I don't need to put in the meters per second. It's already right here in the data table. Next, I'm going to increase the applied force to 150 newtons. Now, this gives us a sum of forces of 56 newtons. Do need to press play to find out what the new acceleration is going to be. Okay, so now that acceleration is 1.12 meters per second. That means that for every second that goes by, the box is speeding up at a rate of 1.12 meters each second. So 1.12. Now, if we push even harder on the box, we get an applied force of 200 newtons. The sum of forces is 106. We press go again, and we can see that it's speeding up even more rapidly because that acceleration is 2.12. You might be discovering a pattern here. And I'll go ahead and do the last one. So at 250 newtons, we have a sum of forces of 156. And our acceleration is 3.12. Okay. So you might be able to, from this, really figure out how that net force would fit into the equation with acceleration. Maybe, maybe not. And you might be able to visually kind of picture in your mind what this line would look like. But I want to make sure we're practicing with the Desmos as well, and that we can really, you can show me what this relationship is between force and acceleration. So we're going to find the mathematical model using Desmos. So I'm going to open Desmos. I'll drag it over here. I'm going to make this one a little smaller. Okay. So the first thing we need to do is it actually says right here, before you do anything else, click on the wrench to label your axes. Awesome. I'm going to go over here and for my for my y-axis, actually, this is a little bit easier, right? What is being affected? That's our acceleration. Okay, and we need to put in the units, so that's meters per second per second. That's the same thing as meters per second squared. Now the x-axis is force, and the question is which force? Okay, so we were using net force to calculate that acceleration. We really want to focus on using net force. And of course, that's in newtons. Okay, so now that labels our axes. Good. And now we're just going to plug in the data table that we have here, right over here. So our force is, when the force is 6, the acceleration is 0.12. We get that first data point on our table. I can press tab to go on to these next ones. 56, 1.12. 106, 2.12. Nope, not, yeah, 156, and that is 3.12. Okay. All right. Slide the A value so you can find which line best matches your data. Okay. Oh, what? It's straight line, linear? Crazy. Awesome. Okay. Delete the other lines. All right. So it looks like this purple one does not fit in our data. So I'm going to go ahead and delete that. And this black line, I don't even know where it is on here. I don't know if that's, okay. The black line does not fit our data either. So we just have our green line, A equals, so acceleration equals this A value times force. And that is 0.02 for the A value. Okay. So we will answer the question below, but don't close this tab. Okay, so I'm gonna just go ahead and copy and paste. So I don't want you to just put in A equals AF. That's not an equation, right? That's two variables there, A and F. Tell me what A is, right? Put in that correctly, and then tell me again what that A value is. If you're feeling real up for it, you can try to describe what that A value means. I'll let you do that part. So the other part that's going to really tell me, did you do this assignment, is if you copy and paste your own graph. So I did create a video for this. You might have seen that, but I'm going to show you just right now. So in the upper right-hand corner, you're going to see this share. Export that image and click download. Okay, cool. Click download. Excellent. Now back in this document, we're going to click on show your work. And we'll go to this image icon. We'll go to my device and go to your downloads. There's your Desmos graph. Open it and add that image. So now it's there and you're done with that question. Okay. Finally, you'll describe this pattern, and I want you to do this part on your own. What does this relationship between the force and the acceleration look like? What kind of relationship is this? As in, is it exponential? Is it proportional? Is it quadratic? Is it linear? That's the kind of thing that I'm looking for. Why did we use F net instead of the applied force? So why did we use the net force instead of the applied force to calculate our acceleration? This part right here will tell me if you understand why we just did what we did. So what I'll be looking for to know that you actually did your own work is that you have your graph there, and that you've told me what that A value is. Now you probably could just get that from this video. I know that I walked you through this whole thing, but really this is practice for tomorrow's assignment. So I'm not too worried about that part. Okay, I hope that you've learned how to do this, and awesome. Yeah, good luck. If you're in fourth period, be sure to come to the meeting as well with any questions that you might have. Second period, you'll probably beat this video to the meeting.